Alright, so this is going to be your video notes for symmetry today. So we've got two different types of symmetry that we're going to be talking about. The first one is called line symmetry. And line symmetry is typically like if you've seen a kid's show that talks about symmetry, like Sesame Street or something. Usually they're talking about this kind of symmetry. So line symmetry is a line that you could fold a figure on and it would match up perfectly with no gaps. And no gaps. Alright, so an example of this, well, we've got this octagon here, and octagon actually has quite a few lines of symmetry, but the first one that most people easily see is just going straight down the middle. So if I were to fold it along that line, there would be no gaps, nothing would be left sticking out, and it looks the same on both sides, right? It's a mirror image of each other, both sides. Okay, so then there's actually also, I can do this for this set down the middle. I can do that this way and this way. But there's actually more lines of symmetry than that on an octagon. So notice how it's got these points evenly spaced too, so we can just go from point to point as well. So then I can do that through each set of points that are across from each other. So on an octagon, we actually end up with 8 lines of symmetry. You can kind of count them if you would like. There are 8 lines. Okay, so that's one example of line symmetry. Another one could be this star here. You can actually draw a line of symmetry through each of the points on this star. So there's one right there. That's the one that people always see. The ones that people tend to forget about is that you can do that through each of the points to get 5 lines of symmetry. Alright, so then there are some shapes with less symmetry, like this one here, this arrow. The only one that I can fold this along is down the middle this way, because if I try to fold it this way or any other way really, we're going to end up with stuff that's that we've got gaps that aren't filled in, and it wouldn't be a perfect mirror image. Okay, and then the last one, we've got this sunshine looking kind of shape. So clearly, you know, we can go straight down the middle just like we did with the octagon and with all the others. These have all had at least that one line of symmetry. And I can do that with each of these points. So there's 4 lines of symmetry. And then there's also these gaps in here, the negative space. And I can also make a line of symmetry through each of those. So that's also going to be a shape that has 8 lines of symmetry. Alright, so we have 8 lines, 5 lines, 1 line, and then another with 8 lines. So that's line symmetry in a nutshell. The other kind of symmetry that we have is rotational or point symmetry. So a shape has rotational symmetry when you can rotate the shape less than 360 degrees and have it land on top of itself perfectly, like look the same as it did before, with no gaps or leftover parts. And rotational symmetry has something called order and magnitude. So order is the number of times that you can rotate the shape before it reaches 360 and have it look like itself again. And then magnitude is the degrees of each rotation. So we'll get to that once we take a look at an example here. So an easy way to kind of take a look at rotational symmetry is to take 2 shapes that are the same. So I've got these 2 stars, and on one of the stars I'm going to label the points 1, 2, 3, 4, and 5. Okay, then I'm going to put these stars on top of each other. So look at that, they match up pretty much perfectly, right? You know, with small errors from cutting. But so what I'm going to do here is I'm going to rotate the shape, and then when it lands back on top of itself again, I'm going to stop. Alright, so here we go for the first one, and it's landed back on top of itself, so that's 1 time so far. And I'm going to see how many times I can do that until I get 1 back on top again. So there's 1, 2, 3, 4, and 5, and now 1's back on top again, so now I've made it a full 360 degrees. So I could rotate that thing 5 times and have it land exactly in the same orientation, looking exactly the same as it did before getting all the way around 360 again. So that means that my order of rotational symmetry for a 5-pointed star like this is 5. So for the star, our order was 5. And so then we can use the order to find the magnitude here. So magnitude is the degrees of each rotation. So how many degrees did I rotate it before it landed on top of itself again? So magnitude is 360 divided by the order. So magnitude is 360 divided by 5, which is 72 degrees. So the order for a star's rotational symmetry is 5, and the magnitude is 72 degrees. So we can do this for a lot of different shapes that have rotational symmetry. So we're going to do a couple more examples here. So the first one I'm going to do is and bear with my drawing skills here, pretend that these, are all the same length and size and whatnot. But we've got this kind of plus looking shape here. And kind of an easy trick that you can use to tell how much, what order of rotational symmetry something has, is you can kind of look at how many things are coming off of it. Like a star had 5 points coming off of it, right? So this plus sign has 4 kind of points or 4 things sticking off of it, right? So that means that our order is going to be 4. And then the magnitude, I'm just going to abbreviate it to mag, is 360 divided by 4. And you can test this again by, turning it and seeing if it looks like itself again, that sort of thing. And it will do that 4 times, because think about it, we've got 1, 2, 3, 4 points, just like we had 5 points on the star. Another one that we're going to do is a little bit more generic. You can take regular polygons, like I've got a regular pentagon. We know it's regular because the sides are the same and the angles are the same. A regular polygon is going to have the same order of rotational symmetry as it has points. Because if you think about the points like things that are sticking off of it like this, or about points on a star, you can think about the vertices on a regular polygon as those points sticking off of it. So in this case, our order is going to be 5, and our magnitude, just like with the 5-point star, is going to be 360 divided by 5, which is 72 degrees. Oops, and I forgot to finish the division over here. 360 divided by 4 is 90. So the order is 4 and the magnitude is 90 for this plus. And for the pentagon, the order is 5 and the magnitude is 72. So for any regular polygon, you can do your order and magnitude this way by just counting the points. For anything like this, you can kind of count how many things are pointing off of it, and that would be its order. Okay, so there's kind of our explanation of our notes here for line symmetry and rotational or point symmetry. Your homework for tonight is going to be to do the next 2 pages. You've got 20.1 here. On each of these, you're going to draw all the line symmetry on this, on each of these shapes. And then you're also going, so first, line symmetry. And then the second part of each one, you're going to say what the order and magnitude of rotational symmetry is, if it has rotational symmetry. And then if it has no rotational symmetry, you just say no rotational symmetry, because some of these don't. Okay, and then on the back side of that, you're just doing the rotational symmetry. So you're following these instructions exactly. For each shape, write the order and magnitude of rotational symmetry. And then if there is no rotational symmetry, just say no symmetry. All right, if you have any questions, come talk to me before school, lunchtime, AR time. We'll get things squared away. Other than that, have a great day.